Wasn't that fantastic? Well done, Emer. I guess I'd like to start with you, actually. Absolutely magnificent story. I loved the way you brought such a human element in to a mission like that. I'm really curious to find out, just going back even before you started on this, what was your motivation for Voyager? What was your motivation for this type of a documentary?
Well, I'm sorry in advance, I've lost my voice, so I apologise if I'm not audible. We've not gone back too far, it goes all the way back to childhood, but I didn't want to have this job. I actually wanted to have Daniel's job. I wanted to be an astronaut. My entire childhood wanted to, mad love of space and, wanted to fly. And I was a bit car sick all the time, so my dad used to laugh at me that it wasn't really quite a suitable job for me. So a bit obsessed with Voyager throughout my childhood, and it had never been made into a feature film before this story. Some TV documentaries had been made, so I just think it's humankind's greatest journey of exploration ever. So when Voyager entered interstellar space, it was back in the news, after such an amazing journey, and it was the time was perfect to make the film. So we attracted interest to make it very quickly, and that's how it came about.
Amazing. Yeah, it must have been like having that desire to do this this interest in it from a child. It must have been it's a huge accomplishment anyway, but to have that for so many years, like to talk to all of these people and get their experiences, personal experiences, what was that like for you as a maker of this documentary?
Whoever said don't meet your heroes was a fool. It's extraordinary to meet these people who've done such an extraordinary job, including Lawrence. You read books and you know about all these people, and you just show up and they're even more amazing and huger in real life than they are, and it was an amazing thrill and an honor for us to meet them, and moreover to find that they were prepared to really let their guard down and let us in on the amazing human poetic journey that they were on. That it was almost like they had waited 40 years being asked about the science, the nitty-gritty of the science, and then suddenly somebody was saying, what did it feel like? How does it feel to be that person who dreamed this up and made it happen? In fact, my camera woman, Kate, at one point turned to me and said, if I hear you asking one more person what it feels like.
But it really comes across because they show such emotion towards the whole mission and the spacecraft itself, which is, from the outside looking in, can be quite unusual to have that emotional connection with the probe. But it was so much more than just a piece of metal going out to explore the solar system and the planets. It meant so much more to them. They had put their heart and souls into this.
And they talk about it being an extension of their senses, that it was their eyes and their ears, and they were projecting in their own mind's eye out to what Voyager was seeing and achieving. And they still feel that way about it, what's in the film is the tiniest bit of the emotion we got in the interviews, from the scientists and engineers. They're massively, attached to it still.
Amazing, yeah. Well, I think it's fantastic to see that, yeah. Lawrence, I'm dying to actually hear from you. This is your first time to see the movie, so.
Yeah, I just saw it for the very first time now. It's an amazing film. I kept thinking, and I think this really says a lot about the film, that if I'd watched the film, I would have said very different things. And that's really important, I think. It really caused me to think in a new way. And it was very wistful watching it, actually, because we filmed it a long time ago and I didn't remember exactly what I'd said, but so many things have happened, and I realize now in many ways it's an allegory for one thing that you don't appreciate, or at least I don't know whether you appreciate, but I appreciated watching it, was this period from the time it was built and launched to the time, after Neptune, but then even interstellar space. The change in our picture of the universe in that period has been so amazing. And for me, it's also was emotional. That was launched when I began my PhD, I realized. And then one of the first encounters was when I got my first job, and then I was a professor, and then my first book, and it was going through the solar system during that time when I was just doing this, and it made me also kind of sad in a way. I heard what I said at the end of the movie, and there's hope, but at the same time, it's amazing that in that short span, humanity has done so much in its understanding, but at the same time accomplished so little in terms of being of the Earth improving, that it's really this contrast I found very moving and depressing, actually.
On that, I guess, I love watching your YouTube clips and videos, by the way. But in that, you talk about science and how often it's, it can just be a list of facts. And we need to get away from that, and we need to look at science as a way of understanding. And through movies like this and through exploring the universe, how do you think we can get beyond just a list of facts for science and communicate that?
Well, it's that exploration aspect that's so clear in the film, and that we don't do with kids. Science is an exploration of the unknown, of asking questions, of solving puzzles, and you see that so much, solving the puzzles of the mission. But I think that taking kids along in that journey of exploration, which they can see in this movie, but it should be something that's done in school every single day. Instead of knowing stuff, it should be a journey of discovery. Every time every kid learns something the first time, it's a brand new discovery. It's not, and it should have a kind of emotion and joy. And it saddens me again that we don't. If we could just express that excitement and understand that excitement and bring them along as if they're discovering it for the first time, which they really are. Not that someone told them it was that way, but they're discovering it. That's what we need to do, and that's epitomized for me in the silent film as well.
Amazing. And for you to see all this new discovery coming from these missions must have been amazing as a physicist.
I'm constantly. It's amazing, and the surprises are what are the best part. The fact that every time we see one, and it's happened with not just of course with our planetary exploration, but with our other missions, that we are constantly surprised, and that's the really important reason we have to keep doing this, because unless the universe is guiding us, and we can't stop looking, because if we stop looking, we give up. We stop evolving as a civilization. So yeah, those are, it's amazing. I also feel immense respect and amazement for the people who actually do. I don't do anything. But I think about a lot of things. But the listening to the engineers and the people who actually made it happen, and also, I know when I teach, I like to teach very low tech when I'm doing experiments, and because I think it's really important to point out that we get too fixated on high tech stuff, but you can learn so much with low stuff. And what you see with that the mission is how it's really low tech. It's the highest tech that 1972 and 1977, but it's really low tech today, and it's still working. And that I find amazing, and maybe we'll get into this, but that's one of the reasons why I'm so excited by not sending humans into space. Sorry, but by how much we can do, by exploring the universe. And I feel, I grew up and I wanted to be an astronaut too, and I stayed home I'm old enough to have stayed home during Apollo missions every day, every time there was a mission. So of course that excites kids in a way I think very few things can, but the fact that I felt with this mission, every time I see a picture, when I remember when we had the Cassini satellite, we had the Huygens probe go, and actually you could listen to it going through the atmosphere, and I feel as much being there with that as I would if there were an astronaut there. And so I really think it's important to balance that humans love sending humans into space, and it's part of what we do, and I don't think we should stop doing it, but we should realize that how much we can get from these little teeny machines, and we should never stop doing that.
Absolutely. Yeah, that's great. And yeah, Dan, it has been in space.
Just
twice.
a tiny bit of space.
And he's actually done 6 spacewalks for people who haven't read up about Dan, but he gave a fascinating panel discussion yesterday, and in that he spoke about being outside in the spacesuit and looking down 200 miles below, and there's like nothing between your feet and the earth. And for the few people who've actually got to experience that, like less than 600 in space, but even fewer still have had spacewalks, I'm curious to ask Dan, in seeing that image sent back of that little blue dot on the planet we live in, and having experienced a spacewalk, which is something so few of us has actually got a chance to do, what were your thoughts when you saw that for the first time? Can you remember?
Well, first of all, I feel like I have so little to add to the amazing story that Emer put out. It's just fantastic. And when I talk about my experience in space, I took a lot of pictures of the Earth, and I have been saying that we live on the most beautiful planet that we've ever seen. And I still kind of believe that's true because of all the variety that you can see from a couple hundred miles up. You know, I'm not a planetary scientist, so but I had seen, you know, I remember when we would do these flybys, and there would be some images, and but to put them all together in a couple hours and experience that whole mission and see the planets, it's just stunning. So I might have to qualify my most beautiful planet in the universe comments, but it, you know, I feel like it was my experience. The Sagan words were sort of what I felt also, which was, you know, you see a dot, and absolutely everything you know, every person you know on that dot. It's a little humbling, but it's also very empowering. I feel it's very wonderful that we can actually see it from the billions of miles away.
Mm-hmm.
So.
And I guess for you, like having been in space, and now you're teaching kids.
Yeah, no, high school teacher now.
Yes, yeah.
Oh, really?
So,
Yeah, yeah. I felt like I should do something important.
Yeah, that is.
Well, I honestly believe that's true. I feel like I make a difference now.
That's great.
So I'm curious, like how is your experience as, going back to what Lawrence has said, we need to take kids on this journey with us. So how you must have so much to translate into that teaching with the kids now.
Well, so what I really think that Emer's done so beautifully here is tell a story and pull the people that created the spacecraft and then did the science and then can explain it and into this, you know, these exploration missions, and it, I think I speak for everybody, it pulls people in. It pulls people into the story. Now you're interested. Now you can't wait to hear about the next chapter. The easy thing for me as an astronaut is I come back, I get to tell the stories about what I did, and the story's built in, right? Because I can tell the story. The story isn't just data or a photograph. I can tell the story, and that pulls people in, and I recognize that, and that's the advantage of my job, and that's one of the beauties of sending people to space. They can come back. The story is built in, and but you know, a work of art like this, where Emer tells that story, and it just pulls you in. I think it's a fantastic thing, and I think we'll do great things for future scientists, future, you know, astrophysicists. But Lawrence made an awesome point that I had never thought about, which is every kid that discovers that yes, gravity is 9.8 meters per second squared by a little experiment, that discovery happens again and again, and I'm going to appreciate that actually now that you said that. It's a really fantastic thing to think about, and we can't stop those moments in our lives even after we get out of school, and that's the beauty of that keeps your mind awake. And
yeah, you really, I mean, but you get that in the film because these people are way beyond school, and they're having the same joy. And
right.
I think that's what's really nice. I think that's what will inspire a lot of kids too, is to see that kind of remarkable pleasure and excitement and the possibilities, because they could do so much with so little back then. But you know what we can do, the technology has changed so much that we can do so much more, and I hope that we'll have the foresight and the ability to do that. Yeah.
What would you like to see happen? So the lifetime of these probes is going to run out in a few years' time. What would you like to see happen next?
Well, there's there's lots of exciting things we can do. One is explore some of the incredible moons you saw, EO, and there's many others that we've learned in Enceladus that we think have deep oceans in them, and we are potentially planning to try and explore them, because we even see organic materials, and we see volcanoes and a bunch of them, and we know that we have this deep ocean that's warm, that has organic materials, that has actually been separate in many ways from us. And therefore, you see, we may find evidence of life on Mars, but the question will be, is it our cousins? Because we have polluted Mars and Mars has polluted us.
Right.
No planet is an island, so if you want to look at a Martian, look at Emer, maybe. But on these systems, they've been isolated, and so if we really could discover organic material, life there, then it would likely be a different, separate genesis. And if we discovered that, then that means there's life everywhere in the universe, or at least life. I don't mean intelligent life, but that would be. So anyway, that's one of the profound things we want to do. But we're looking at other planets that may be more exciting, but ones that were just not in our solar system. And I've never thought in my lifetime that we might be able to image exoplanets or see them and look at their atmospheres. That's an incredibly exciting field. And of course, there are questions. I could go on, but we are living in I just gave a talk the last week, and we're living in a time like Galileo. We've opened a new window in the universe. Gravitational wave astronomy has opened a window in the universe that was unheard of before, and it's really like looking at the moons of Jupiter. So it's an exciting time, and there are lots of possibilities.
Yeah, and how have your thoughts and outlooks on things, if they have they changed since all of these discoveries, exoplanets, and all of these discoveries have moved on over the past decades?
Everything has changed. My picture of the universe in 1977, which was typical of others, was totally different. Everything we thought we knew about planets, on the whole, has changed. Everything. Not just the planets in our solar system, but the possibility of what types of planets orbit what types of stars, and how many stars have solar systems. Our thoughts about what the universe was doing. We thought it was slowing down and speeding up. Absolutely everything has changed, and I hope that will continue, and that's why doing science is exciting. It's not because validating what you know, but it's finding out you're wrong, and I think that's the most exciting thing.
I'm going to ask just one or two more questions. I'd like to open it up to the audience as well for a few, because I'm sure there are plenty of questions out there. Emer, I guess for you directing this, did you have one or two major things that you took away? Did your perspective on the notion of one creator of the universe, or any of those elements, how were those impacted by speaking to all of these people and understanding what they were doing, and the probes going out and the discoveries they were made? This whole journey that you've come on in making this, I'm just curious as to how your vision on the universe evolved.
I really enjoyed, as Lawrence will remember, that each interview was 3 hours, nearly 3 hours long, over 3 hours long. The editor didn't thank me for it, I'm afraid. It was so much material. We talked a lot about, obviously, the practical stuff, the mission and all that, and we spent a lot of time just ruminating on the philosophical questions, as Lawrence calls them, the cosmic questions, the primal questions that contemplation of space kind of kicks up, and over the course of all the interviewing and the course of all the screenings we've had since we started showing it in the last few months, I was very interested in what sort of conversations would spring up in audiences around, all those ideas to do with, is there anyone out there, or how do we get here, is there a creator, and all that, so it's been a really interesting journey about all that nuanced philosophical conversation, So, only two of the scientists in the interviews talked about belief in God, and one of the scientists, quite a profound Christian, says God loves science, and so, and then there's others of us that feel whatever
quite
different way.
Would you care to elaborate, Lawrence? Or?
You don't, my views are known, but I think the universe is the universe is so much more exciting than the Goat Herder's Guide to the Universe, which was written 2,000 years ago. And that's wonderful. That's great. And so I find it severely limiting to think that some people's view of the universe is the same as the Goat Herder's Guide to the Universe when all of this has been discovered since then. I just find that tragic.
And Dan, I guess just looking at that, you've seen this a few times. For you, having been in space as a human, and the coupling now between, going to Mars and sending probes, what would you like to see happen in terms of probes and astronauts working together as we move forward?
Well, so in terms of humans in space, we're really just a couple hundred miles away, and we're trying to get to Mars is probably the next stop, and that's just right. That's like here compared to these distances, and but the challenges that we're going to have even going that far, and not just getting there, but I've been talking about the time delay. When we go to Mars, it's a 15-minute delay from speaking, and then 30 minutes. So conversations to your home will no longer be possible. It will just be one-way data dumps each way, and that's the psychology of what those missions are going to be like are going to be completely different. Looking at the last scene of the movie here, where it takes 18 hours to get, and that's the speed of light. So light is traveling, or electromagnetic energy, light is traveling. And it's taken 18 hours to get here, and so I'm excited as an astronaut and a former astronaut. I'm excited about sending people further out, but it's a completely different game. I see this. I don't see this space movie as something that's astronauty, because the scale is just so much.
Yeah,
different.
astronauts will never be doing. I mean, we're not. I mean, in the foreseeable, in the imaginable future, we'll not be exploring EO
right.
And do you agree that the people out here keep thinking that Mars is going to be colonized tomorrow, and it's not. It's a damn hard task, damn expensive, damn dangerous, and it's going to be a long time. Yeah,
yes. There are technical and other huge hurdles that we have to cross. Although this is a side note, but I will have to say that I've thought the biggest problem getting to Mars is going to have the various nations that we're going to have to cooperate, have budgets and policies that will support that. But now we've got this crazy dreamer in California that's building spacecraft and rockets, and he wants to go to Mars, and he won't be bound by budgets and or budgetary processes, so he might get there.
Yeah,
and
well,
so we'll see.
Someone I know, and I think it's one of the times he's wrong. But we will, speaking of the delays, one of the things it's a very impractical, to the extent that anything I'm involved in is practical, this is it, but it's incredibly impractical. But I'm involved on a mission to send a little spacecraft to nearest, to take a picture of a planet around the nearest star to go at 20% the speed of light. It's a 1 gram size spacecraft, and this Russian billionaire has funded this program, and me and some other scientists are on the advisory group it pushes the edge of technology, but maybe it'll be the next 35 years before it gets there. It's time to stay healthy, and maybe.
But I think without those visions and those bold ideas, we're never going to really move off and learn or explore. So.
Well, entrepreneurs say it all the time. If you don't fail, you're not really pushing the edge.
Yes.
And and for it's amazing these things work, but there's a lot of things that NASA's done that haven't, and it just has to be the case when you're pushing the edge of technology.
Yeah,
and that's why human space travel. I admire their bravery among many other things. Also, I would have loved to spacewalk.
Yeah, of course, yeah.
But we learned. This is another reason I think that people don't realize how dangerous it is. The shuttle was probably the most highly engineered, carefully controlled. The craft of anything, more than the airplanes all of us fly on, and yet 2% of the time people died.
Yeah.
2% of the time. And so I don't see that as changing either. And that's a reality that I think few people are willing, especially entrepreneurs right now, are willing to realize. You send 100 people into space, 2 of them die. If they're tourists, that's not good for your company.
Emer, I promise I'll open it up to the audience soon. I have a super easy job actually with such a rock star panel this evening. But what's next on the cards for you? You have a busy time with the film, but I'm curious, this must have set wheels in motion for more really amazing films.
Yeah, we're still busy going through all the publicity to do with this now. It's on its journey. It's being released in Ireland in a couple of weeks and then following on other countries. So that's taking our time for the moment, and I'm developing a number of projects that hopefully towards the end of the year I'll get a chance to do some proper work on.
Fantastic.
Can't say what exactly is going to fly yet. So.
Fantastic. And just going back to making the movie as well, often we have these visions of what we want to do and what we'd like to achieve, and it's never really a straight road. It's bends and twists and lumps and bumps to get to the end. So for you, did you have any, would you like to share anything like that from your journey of going from your vision to having this amazing feature?
Documentaries in particular, there's no script. Although we did have quite a good script for this, in the sense of the story. We knew the story of Voyager, all the planets, and straight out in terms of what it achieved. And then the Golden Record was always conceived as a kind of a little divertissement off that main story. So we had a very strong script and knew where we were really headed. But of course, it had to get torn up once we met all the characters, because they just brought so much humor and humanity and life and madness and joy to the whole thing that really we just tore it up and started from scratch again in the cutting room, building a story out of people,
Yes.
people's lives, people's dreams.
There you go. It's everything constantly evolves, I guess, as you move along.
Yeah.
That's fascinating. And speaking of the Golden Record, Dan, I'm curious, no pressure that you're, one of humanity's representations in space as an astronaut. What was when you learned about what was on the disc and that, what were your thoughts?
I remember putting together the record and talking about, the discussion about it. So, and I was in, I guess, high school, but watching the film and thinking about it as an adult, the record, most likely will never be discovered, heard, or used. But the process, just the process of going through and saying, okay, I've got 6 weeks, I've got 2 hours, I've got whatever kilobytes of data that is, and I'm going to distill, the human story into that is a fascinating process. And then, I'm sure there are people that are upset that other things were not included, and you can understand that. But that's just that process was probably very valuable for the people that were involved. And I didn't realize Drake himself was involved in making the record. That's fantastic.
Yeah, he and Carl were,
Yeah.
and there was a lot of interesting discussion at that time. And I was thinking how, well, it's maybe a good thing and a bad thing that it happened in 1970s and not 1990s. First of all,
you're right.
Probably, first of all, they would have played the music from the 1980s, which
That's worthless.
But more than that, so they wouldn't have a record then, right?
It'd been a disc, right?
A disc,
Yeah.
and so the
Too
first
much
thing that I
data.
thought, the first thing I thought about is that if it's ever discovered, they'll say, boy, they're so quaint, they have these records. But then I'm figuring, well, everyone's going back to vinyl now, so maybe they'll.
So hip.
And what about you, Lawrence? Would you have put anything different or?
Well, yeah, I would have put some naked pictures on it for sure. Absolutely. No, I mean it was arbitrary, and I think all you want to do all you want to demonstrate was diversity of life, the fact that there is life, and I think the fact there was music was great. Probably too much music, I think. Probably, I think that was romantic, but you could probably have taken some of the valuable data and done other things with it. But I don't think it was arbitrary what you choose. I don't really think it meant. But it would have been nice to have an accurate biological representation of human beings. So.
Okay, if you have any final thoughts, I might open it up to the audience, because I'm sure there's plenty of people with questions out there. So anybody want to ask some questions to our panel? Yeah, I can see a hand in the front row.
It was a really great film, and it was a really hopeful film, I thought, but not to sound cynical or anything, I was just wondering what your guys' opinion is on the militarization of space. Do you think that's inevitable? Do you think in our lifetime we're going to be seeing missiles and stuff there rather than just satellites and Voyagers?
You can start.
I'll quickly say.
I'll be more pessimistic than you, whatever you
maybe.
say.
Yeah, well, of course I'd hate to have that happen, and I think what people are discovering is it's really hard to do militarization in space. To create something, either a shield or a weapon in space that's effective, is really, really hard to do. And so my optimism is that they may try, but I don't think it's going to work. But.
Well, there you go. Let's see. First of all, it's important to realize that much of space exploration is incredibly driven by nationalism and not science. I've had debates with someone you know of in the States who most of what was done in the 1970s, certainly the exploration of the moon, was not done for science. It was done for national prestige, and you're seeing that now. You're seeing a space race as more countries try and demonstrate that they can do something, and so that's going to continue. That is driving space exploration as much as anything else. Nationalism, national priorities, and militarization is just part of that. What is true is that it may not be good to have space weapons, but what is unfortunately true is that we rely more and more on information we get from space, and therefore, if you were thinking of offensive technologies, what you might do and what people will do is to target things in space, because we rely so much more from GPS and so space will be a target, and therefore, in that sense, I think it will be a battle zone if we in the event of some kind of war, and I think that's just near space, and that's just kind of inevitable. And beyond that, I don't know.
Question for Lawrence. I can see why you would prefer unmanned exploration. Would you agree with Stephen Hawking that if we don't move to another planet within the next couple hundred years, we won't exist?
Well, Stephen's a friend, and I agree with him about some things, but I think, look, I think it's really important to try and exist on our planet. I do think, I think our future's in space as a civilization, if we survive for a sufficiently long time. There's no doubt we want to hedge our bets. The Earth is a target for asteroids, and we may be able to deflect them. But if you want this, if you want to preserve it, you want to have pockets of civilization beyond this one target. So I think in the long run, that's the case. But I think people who view space or Mars as some big hope, Mars is an awful place to live, and so I think we have to recognize where our long-term future is. But long-term is not the next decades, in my opinion. I mean, we'll explore, but I don't think it's the refuge of humanity in the near term. We can't get our act together to here, and I think that's far more important, in my opinion.
I second that.
Does somebody else have a mic, or
Yeah, just
and then I'll come to
okay.
That's good.
On a project that would traverse 10 administrations, how big is the challenge of maintaining political and financial support? Was that a big factor? Was it all engineering? Was it all, I suppose, new science? Or was actually politics a big part of this?
One thing I can say is in the United States, it's a real problem, because projects can be approved by many administrations and then be killed. There's no permanence. You can get a project I was involved in, the Super Collider, which is a big accelerator, was approved by 3 presidents but then killed. You could the James Webb Space Telescope, which we hope will fly next year to replace the Hubble Space Telescope, it could have been killed last year or the year before, in spite of $6 billion being spent on it over 20 years. There's no permanence, and there should be some funding mechanism that says once it's been approved, and once it's been approved by these people, you can't kill it like that. But that's not the way it works, and that's a real concern for any space mission, actually, any of the ones that are being proposed, but for any big science. And unfortunately, for better or worse, as we push the forefronts of science, it gets big because it gets harder, and you need more people. That's not just physics. That's biology as well. The kind of resources you have to amass are large, and you need some guarantee that if you're going to invest those resources, it's going to continue. And it's tragic when they don't, because can you imagine, for example, all the people you saw in this film who may have devoted their whole professional life to this project, having been approved if it had been canceled the day before. And that's what happens. You have people who've been trained and can give so much to the world, and you just take it away. And there's a whole bunch of personal stories that you get a sense with this film, I think.
I'd like to add to that. When I watched the end of the film, I thought, really, somehow there's a budget line item for this office space, for the Deep Space Network to point to the thing every, I don't know, week or however, I don't know how long, every day, to get data, to collect it, to amass it, and its primary mission was long over.
Yeah.
And so somebody's very clever in hiding that line item.
You're right.
Because it doesn't. It's fantastic that it's happening, but it's hard to imagine it being approved as a line item in somebody's budget.
And I was thinking that too. The last words, the film which you talked about, the last signal we'll receive. The last signal we'll receive may not because it's not
Right.
they're sending anymore. It may be because someone's decided, like some idiot who's in the White House now or something, that it's just not worth it. Turn it off.
Yeah,
we need to do something else.
That's right. That office space is needed for something else.
Yeah,
Or the
yeah.
satellite.
Wouldn't that be sad?
Dishes are needed. Yeah.
I think as well, when you see what's happening now, the commercialization of LEO, and hopefully that will spiral to leave more of government budgets open to these science missions. Anyway, we'll see what happens. But there's a man here in the front row.
May I ask a question about education? I was absolutely thrilled that, number one, your film is such a tremendous educational resource. I would love to show even parts of it at some time in the future in school. And secondly, I love what Lauren said about children and discovering that science is not just facts, but all the time new discovery. And thirdly, I'm thrilled that Dan has become a high school teacher.
Yeah.
So my question is, in addition to educating children, which I think is easy, and so
Not easy.
Okay.
Right, it's easier than educating adults.
I guess that's true.
That's my question.
Yeah.
That's my question. So my question is, how do you think you can bring your wisdom to more politicians about deserving?
Oh, wow,
Wisdom
that's the
and
hardest
politicians.
question in the world. Look, I think, no. Max Planck said science progresses one funeral at a time. The same is true of politics, happily. And I guess I kind of feel like the children are the future, and the adults are a lost cause too often, especially when it comes to current politicians. They're not leading the world at all. They have to be led. In almost every area you could consider, they're not far thinking, they're far reaching. They have to be pushed from behind, and so I think what we need to do is educate the leaders of the future and hope that we survive that long. That's the first thing. But I think I've tried in my career at various times to try and I think everyone gets excited by this stuff, and ultimately, everyone is fascinated by science. Most TV producers don't realize that, but everyone is fascinated by science, even politicians. And so, if you can pick on it, if you can really get them going, but you have to have a way to communicate to them, and that's the hard part. And for example, in my country right now, the Office of Science is closed down, and there's no science advisor to the president. And so one needs to open those levels of communication. But the bottom line is, I'd say, what Dan's doing. The children are the ones we need to get.
And just in terms of the film, happily here it's gotten a G cert, which means, you know, open to all ages. So hopefully that'll be the same where it's travelling outside of Ireland as well. So we're, you know, it's kind of a film for all the family. So reaching children that way, and I think it will be travelling through schools and all that after it's had this particular part of its life. So.
Thank you very much.
And I should say, by the way, that means that you all have to do your part, right? I mean, everyone has to be an evangelist for science, and it's the only way it's going to happen. Being motivated by films like this, but to push in the voter box and everywhere else. It's not. It's important that some scientists communicate, and that's nice, and it's a big, high-profile thing, but the public, the only way it's going to happen is if the public gets behind that. And that means, I guess, we have to communicate to the public. Anyway.
We have time maybe for one more, and then we'll wrap up. Oh yeah, David.
Question really for Emer.
Especially for Amy, despite her poor voice.
Thank you.
Well, this is my second time to see the movie, and I'm looking forward to the third time. And I know you've had success selling it, or you have partners who are going to screen it on TV broadcasts around the world. I welcome actually to hear the list. But will it be shown then as a 2-hour documentary feature film, or will it be edited down to a 1-hour documentary or 2 one-part? So when we say it on RTE, probably next year, I believe, we'll be watching what we just saw or something else slightly.
Yeah, and it's different for all the territories. Claire, my producer, so she might be able to fill us in a bit more of the detail, but RTE are going to show it as the full feature film, yeah. So it's different for all the territories. BBC are going to take a 90-minute version of it. PBS have done a different television cut, so you know, it kind of changes from territory to territory.
And do you know when RTE are going to screen that?
I'm not quite sure yet, no.
It won't be this year, will it? Or
Maybe later, yeah, this year, yeah.
Okay, thank you.
It's on cinema release here first, and then
Yeah.
some point after that. Thanks, Dave.
Super. So, oh yeah, there is one more at the back. Sorry, I'm blinded by the lights. Yeah.
Techie question, nerdy question. Do you see any technological advancement, promising ones, to make this kind of trips speedier?
Yeah, well, yeah.
Smaller, right?
Well, I mean, we're doing it in the solar system and things. There's electronic propulsion. There are ways we can now move smaller objects faster and explore the solar system, and that's happening now. And the objects we'll send to the moons of Jupiter and Saturn will travel much faster. But as I say, we're actually working on something that'll go at 20% the speed of light. In 2 minutes, if it works, in 2 minutes it'll be it'll go out to 6 times the distance of the moon, at which point the acceleration will stop. But the great thing about that is, and I don't know if it'll work, but if we can produce objects like that, we can explore Jupiter every week. Okay, I mean, it'll take 3 days to get there, or 3 days to send a flyby of EO. But these are very small things. But what's great is and that's what happened. You think of in this wonderful movie, you get the sense of this 20 years of Voyager. But the human technology has changed so much in 20 years that we could put a lot more on a little 1 gram satellite or spaceship than we could in many ways on Voyager. And so there are great possibilities, I think, for the future. And smaller is better in that case, definitely. When it comes to space, smaller is better, because weight is the huge enemy of space.
Yeah, and not going down to a gram, but now, first of all, you can make a satellite this big, and it can do interesting things. And now, not only is it smaller, but it's cheaper, and so universities, even high schools, can now create their own satellites if they can figure out how to get a ride. But that works. But so that's a technology that's a technology advancement that has allowed remote sensing or any kind of space kind of things to be put into a sort of a 4 centimeter cube, whatever the cube unit is. But that's fantastic, but, right, because F equals MA, if you can make M small enough, you can get the A big, nice and big, and if you can get them way down to the gram size, that's fantastic.
Yeah, it opens up space exploration to beyond, to smaller scale, to individual groups that can maybe manage a practical economic situation of sending a small satellite. So I think there's no doubt there's a big area called CubeSats, and we just had a postdoc at my institution become a PI on this who just developed one of these things. That would never have happened before, where someone at the beginning of their career would suddenly be the primary investigator, but because they're small, you could do that. And to come back to you in a way, that's why I think if we ever send humans to Mars, it'll be one-way missions, because the big enemy of that is the fuel that would be required to bring them back. So you could send a single mission to Mars and keep them provisioned for their entire life for less than the cost of a round-trip mission. So mass is the problem, and humans, unfortunately, are massive.
I think I saw a few more hands up. Did I? Or oh yeah, I see. Sorry, the lights are.
Okay.
So the excellent movie, was fantastic watching it. My question is for Dan Lawrence, really. I know whenever the Voyagers were being launched, there was some opposition to sending plutonium as the fuel source. And of course, it's the only thing that can power it for long enough, so the panels wouldn't work so far away. But interestingly, I think with Io, or perhaps it's Europa, I've heard of an idea to get through the ice, to have a plutonium source that would actually melt through the ice to get into the water of the ocean. But of course, the concern there is, with the second genesis, would there be contamination involved? And I suppose my question is it worth trying to take these risks to find other life, or maybe, as Stephen Hawking said, maybe we shouldn't try to find other life, we shouldn't use signals to find other life, we should just, in case, they come to a planet or whatever, but I suppose, should we be so concerned with finding other life, or should we not take risks, I suppose?
I'll start. That was huge controversy of launching these things with a reactor on board, and as explosion-proof as you can make them, it required, of course, special approvals to launch these things. But it's such a small part of the story here, but it's the most miraculous thing that it's a power source that they talk about 45, 55 years. Is that the expected life of the EPG, whatever these things are called?
No, there'll be still power after that, but it'll lose lock on the Earth, I think.
Oh, I see. So that's a miracle of 1970s engineering. Are these? I can't remember the acronym. The power sources, the nuclear power sources, RPGs. Yeah, RPGs. So, I just remember the huge controversy back then, and now you can't get these discoveries without them. I hadn't thought about if we're going to go further away from the sun, you can't use solar panels. You just that's how you're going to have to get your power. So I hadn't thought of the impact of landing these RPGs someplace else, but
there was a huge controversy, but I think it's a non-issue compared to the other risks. Everyone's afraid of radioactivity. In fact, in many ways it's far safer. It's far safer than coal, and it kills fewer people.
Yeah.
It's a lot easier to detect, and so it's necessary. But again, the good news is, as you make smaller spacecraft, the power supplies are much smaller. This is huge. This is what was it? You said it's a school bus size. What's the word?
Kilowatt or
Yeah, and so to power a school bus size satellite is very different than powering a few grams, and that's what's wonderful. So you'd be able to use radioactive power sources, which are essentially almost undetectable, and certainly not dangerous. I think that's so. I think it's a non-issue in the future.
I have a question for you on the basis of that, riffing on that, about the search for life. I always thought my whole life that were we to find evidence of extraterrestrial life, that it would be like a game changer, you know, be a paradigm shift in our understanding. The last few years I'm starting to think it would almost be like a headline or a t-shirt for a day or two and then we kind of move on. What do you think? What do you think it would change everything?
Well, I mean, it depends what kind of life, of course, right? I think it would be a huge discovery, but I think you're right in the sense of, so if we announced every week, every few weeks there's a new quote unquote habitable planet discovered, which is really not true, right? We don't know if they're habitable in any way. We make some assumptions, very crude calculations that suggest there may be liquid water on them, but there's no way do we know that they're habitable. And that should have been a major discovery, right? That the Earth is not the, and now we're hearing about it all the time. I think if we discovered life, it would be a dramatic thing. But I used to think, for example, that it would be a game changer. And I think that in many ways we're so ingrained in the way we do things. I think even the discovery of intelligent life elsewhere in the universe, I guess maybe I become jaded. I think it would be a profound, certainly it would be amazing, and I'd love to have that happen in my lifetime. Would it change life on Earth? I just don't know. I don't.
You might be able to add to that actually, Dan. You made some good points yesterday when you were being asked about perspective, your perspective in space, and if everybody on Earth could have that, would it change life on Earth? And I really liked your answer.
Well, I had the privilege of looking at Earth for a couple hundred miles away, so I can't see individual people, I can't see individual cars or buildings. And I see mostly the geographic Earth, and it's beautiful. And from that perspective, I could look down and I know that there's awful things. I know there's people starving and awful people. I know that all that's happening, but for that moment, I have the pleasure of seeing the Earth as a beautiful place, and that moment lives with me still. And so I wish that many, many other people could have that experience and remember that it's a beautiful place. It doesn't make the bad stuff go away, but for that moment, it lifts your spirit of your home planet, and that's sort of how I feel about the privilege that I've had about seeing our planet from a different perspective.
Great. I think maybe we'll wrap it up. There's no more questions from the audience, is there? Oh, one more. Okay. So we'll take one more and then.
I was hoping to go drinking.
Yeah, I was wondering what the pubs close at Temple Bar on a Sunday night.
I have a question for Lawrence.
Oh, yeah.
I felt a bit weepy towards the end when Voyager left Neptune and wandered into interstellar space, so I can't help but wonder, you were working for so long on such an amazing project, and was it easy to, when it ended, to just move on? Or did you feel something like postpartum depression? And how do you think it affected your future choices?
Well, first of all, you should realize, I other than being a scientist, I was not working on Voyager. I mean, I used the information from them, but I wasn't part of the project team in any way. But for me, it was actually far more uplifting than negative. And I guess I tried to give, well, at least the clip of mine. I probably said a lot in that 3 hours, but the clip of mine used really reflected my thought that there's this minuscule hope. I don't have great hope for humanity, I'll point that out, but we have done one thing, at least, that's going to be out there for at least a heck of a long time. And so I find the excitement, the fact that it left the solar system in my lifetime, uplifting. So I guess my attitude is to some extent the same as attitude I have about my children, my daughter, my stepdaughter, which is, it's sort of wistful when you look back on childhood, but by far more exciting to think about what they're going to do in the future.
So just to say thanks so much to everyone for coming along tonight. Huge congrats to Emer and all the team. I know there's some of the crew in the audience tonight, so just a massive thumbs up. Congrats on an amazing job.
Thank you very much.
Yeah, I agree. Well done.
Tell your friends to go when it's in the cinema, please, if you can.
And to Lawrence and Dan, obviously our two other panellists, thanks so much for your time. That's a wrap. We'll see you soon. Have a good night.